Okay, in this video, I will show you how to write code for multi-mode LED and 7/7 controller with buzzer. So it's use the Arduino multifunction board, and then the project specification is as follows: open power up, then all LEDs will toggle at interval of 500 milliseconds, and then if S1 is pressed, then LED patterns 01, 001, 0011, and count will alternate continuously at interval of 250 milliseconds. And then if S2 is pressed when right, then 77 display will begin counting at interval of 100 milliseconds. And then if S3 is pressed and held, so the LED patterns will be 1000 or 100, and will alternately display at interval of 350 milliseconds. And then, okay, during this mode, buzzer, okay, if I forgot, buzzer will remain on, mean buzzer will on, and then when released, then buzzer will off. Okay, all right. So first thing first, we need the right. Okay, we need the PA1 input, PA4 as input, and then PB0 as input, then PA5 as output, PA6 as output, PA7 as output, 1, 2, 3, then PB6 is output, and buzzer PB3 output. Then we go to system view, to PIO, then we set all that pin, not all that pin, PA7 open drain, PA6 open drain, not PA5. Okay, then PB3 open drain, and then PB6 open drain. Go back to pinout view, then we need to set PA8 as output. This pin for the multi-segment, multi-segment PA8, PA9, and then PB5. Okay, right. So that one no need for us to set it to drain, open drain. It's require the push pull, push pull and push pull. Okay, then generate code. Oh, okay. Before I forgot, you have a 7 segment there. So for the 7 segment, I will use a timer to display it. Okay. Okay, let's go back to the timer. Timer 11. I will use timer 11. So timer 11, APB2. You can go to APB2. So you need to set the clock configuration first. Set to 60, for example. So APB2 at 60 meg. So APB2 must be 60 meg for 4 millisecond, and then at 4 millisecond because we need to multiplex it. Multiplex this one. We have 4 segments, 60 time frame per second. So 1 over 4 multiply 60 equal to 0.0041704 millisecond enough. So division is 1, PS 3000, and PR is 80 for the timer. So we go back to the timer 11, activate it, then go under the parameter setup. So this one should be 3000 minus 1. This one should be I think 80 minus 1, no divisions, and enable. Okay, then don't forget to enable the interrupt. Regenerate code. Okay, so then include all these three files. We need to include the LED and switches, multi-learning segment, 7/7, and user tick. Okay, include it. Alright, then go to top one here, found inc, include double quote, yeah, user tick, enter, found inc, control space, double quote, multi-segment, enter, then found inc, control space, let and switches. Okay, so all that three already included. Next, we go to the okay, we can go straight to the timer under driver, hall driver, right? Hall driver, source. Then we go under the find out. Oh, sorry, not hall driver. Oh, I make a mistake here. Not depart. Call source, right? Driver, STM hall driver, include, and then find timer. Then window, subview, align. Then find out the why it becomes so weird. Okay, so find out the team, whole team period elapsed, copy it, then go to the main. Okay, go to under place it under begin, enter, and then this one is actually we just going to multiplex, multiplex the 7 segment. So what you can do is just write down if open bracket steam instance is equal to team 11. Okay, next, then we just multiplex, right? Just call it multiplex segment. That's all, right? That's all for that. Okay, then first here, we're going to use the 7 segment, okay, for all right, to display, okay, number up to 100, right? Number up to 100, so we can write down on off segment. This one is off segment, and then we on the segment, then we on this segment again, and then we on this last segment, right? Because we have 3 here. Then we okay, we have buzzer, right? Better you off it here, buzzer off, and then after that, then we can have the, we can set our timer, how team underscore base start IT steam 11, right? Then we have something to display, right? We have something to display. What we're going to display is this, the count here, right? Counting count, right? So we're going to display the count. Okay, maybe you can write down the count here. UINT 16 underscore T CNT equal 0, right? So you can display the count here, convert count, right? Count, and then display it, then set the statistic. I use one only in this case. Okay, this is a simple way writing code. I see you. So if get statistic 0 for 10 out of 10, so it's 10. So we run the state, right? So switch state 0 and then enter case 0 break, right? So we divide our problem into number of case 2, 3 and 4. Okay, so here we have a case. So say this one is case 0, case 0, this one is case 1, this one is case 2, and then this one let's become case 3. So we have 1, 2, 3. So 1 and 2 and 3. Alright, in case 0, so we have state here. Copy the state, then place it here. int 8_t, right? So we have state 1 equal to any number other than 0, because we want to use 0 assign or initialize state 0 to 0, right? So when it happens, then we will copy. If state 1 is not equal to state 1 is not equal to state 0, then we will copy state 0. State 1 is equal to state 0. We copy it, right? Copy it. This is the first thing that we will do. Then what is the other thing that we do is here is to for up all LED will toggle interval of 500 milliseconds. So we will toggle the LEDs, right? 500 milliseconds. So we need some sort like loop. We set it to 0. Okay. So we copy this loop first, right? And place it here. Okay. So we can use uint 8_t for that loop. So if loop equals 0, then we do something like to toggle it. We're going to toggle the LED, right? The LED. So the LED is, say we have a variables, say let's buffer equals 0, set to 0. Then here we will toggle it. So let display whatever that inside the let buffer. Okay, I need to copy this one first. Okay, let buffer equal to 0, then let display will be let buffer, right? So whatever inside let buffer will be, right? Then after that, then we let buffer to toggle it. We can use SO to toggle it, right? Let's buffer 0B, all that 4 bit 1, 2, 3, 4 will be toggle. That's all for that, right? Then we repeat it for 500 milliseconds. So if plus loop greater than 50, then we say loop equals 0. Okay, so this is the first side, right? So we will carry on in that way, right? Until what? Until we press a button. So if I can write down one by one, if switch, so we read the button now, SW1 is equal to SW node, and then SW node is equal to get switches. Right, get switches. Okay, remember to copy this one first and place it on top again. Sure. UINT8 underscore T. So this one we can set it to 0. This one to any number, right? Okay. So if that if SW0 equals 0 and SW1, sorry, if SW1, previous one is not pressed now, SW1 is equal to 0P001, right? Then we can see that state 0 equal to 1. So we jump to next state. Same thing, you just copy this one. Okay. Else if 1 0, so we jump to state 2. Copy this one again. So we jump to state 3. Right? 1 0 0. Okay. Okay. So this one is the line we read the push button. Okay? We change the state by this. But this one is only repeatedly. We do something repeatedly. This one only at the beginning of the code. Right? The beginning of the code. Okay, right. So settle that one. Now we go back to the second one. The second one is when S1 is pressed momentarily, let pattern blah 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 will alternate continuously. Okay, display. So first thing first, I want to put it here. Right? Constants array. So sorry, UINT8 underscore T array equal. Okay, so I'm going to put it here. Right, so all these I will change to 0B to binary. Right, and then I need an index. Index int8 underscore. Index normally I will use int because sometimes we will decrease it. So int idx, right? So name it as state. So 1. C, same with this array of state 1, right? Okay, so what we need to do is, so when it happens here, right? When it happens here, same like this, right? So we will set the now we're not going to use a black buffer, right? We have a loop, of course, and then but now we have index, right? Index s1. So we will set that index s1 to 0. Okay, then we say that if, okay, so what we're going to do, we're going to do this. I copy this and place it here. So so when the loop is equal to 0, so like with display will be whatever in the array s1 of index s1. Then I will increase that index if index s1 is greater than the size of array s1 minus 1. then the index S1 is equal to 0. So we start again from the first one, right? Now, okay, at the interval of 250 milliseconds. So at the interval of 250, so 25. So loop becomes 0. Next, we need to, okay, again, repeat this one. Just copy this. Okay. So now, what we do have is only this one, right? If previously 0, and then you press it, then the middle one or the left, the most left one, S2 and S3, you press it, either one, so you jump to state 2 or you jump to state 3. Else it remain here, right? Else it will remain here. So settle for the second part, and now we go to the third part. So the third part is when S2 is pressed on 3. Okay, I will do the last part first. Press help continuous, let blah 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 will be, the pattern will be, okay, so I copy this one first, and then I put it on top, right? So first thing first, I need the index, I name it index S3, right? Because that is state 3. And then I put constant array or uint 8 underscore t array S3, because that's state 3, equal colon, and then I place this one. Okay, so again, you have this, we need to change it to binary, change code, right? Okay, so the code will be something like, okay, first thing first, when it's happened, we copy it. So what we do have here is loop and S3, right? Loop and S3. Then what next that we have is this. When loop becomes 0, then we display S3 of index S3, and then S3, S3, and S3. Then the loop now is 350. This one, right? 350. So this one needs to be changed to 35. Okay, so settle that one. And the last one. Okay, the last one. Read this one carefully. He said that when S3 is pressed and held continuously, that means when you press, just press and hold it, right? If you release it, then it will change from 3, from 100 to 0. Okay, so we just look for 100 and 0. Okay. Other case will never happen here. Never happen. Okay, so when it jump, then we check the push button. If you release it, then okay, this one should be 0, right? Okay, so when you release it, then we jump back to 0 to see that it will jump back to 0. Yeah, and the LED will revert to toggling, blah blah blah, and then buzzer must be on, remain on. So you can set the buzzer here to on. When you jump, then buzzer will be on. And then when it is released, state change to 0, then buzzer 2 will change to will off, must be off here, right? Must be off. So we settle the third problem. All right. Next, we can do the other things that, okay? The third one, the second one. So the second one's the problem almost similar, right? Okay. So what we do is when S2 is pressed from 377, this way we begin counting at interval of 100 milliseconds, running over to 0 once it reaches 100. Okay. So first, we don't have index here. We have a loop. Yeah. So we can have another thing such as count CNT equals 0. Right. Oh, actually we have already, right? We have already here the we use already count here, right? CNT equal to 0. So we set count to 0. Then each time the loop is equal to 0, then we will update the the LED is not defined here. Okay, it's not defined here. Okay, I off the LED. Okay, so I off the LED here. So when it started then here, then let's see the LED will be 0, right? Will be clear, right? Clear the LED to 0, off. Then the loop start to 0. Then then we update the multi-segment, convert segment counter. Okay. Then we increase the counter if plus CNT greater than 100. Yeah, count equal to greater than 100. Then CNT equal 0. Okay, so that's all for that. Yeah, we will carry on that way, that manner. And then if plus loop greater than 10 multiplied to 10 is 100, right? So loop become 0. Okay, last from here. So if okay, I love to copy this one, right? Okay, better I copy this one. So if get switch, then now we are in this state. So take this one out, right? So if press S1, then jump to state 1. S3, then jump to state 3. Okay, that's all. I think, yeah, that's all. So as you code again, I compile it first. let's check the code. Takes time to compile. That's why I don't like to compile. Okay, I think everything is okay. So like, so like everything is okay. Okay, no problem. Okay, when started, then we can see that the buzzer will be off, right? Then we on only 1, 2, 3 segment, right? The first segment will be off, right? The 1000, right? 1000 segment will be off, and then we convert, means display, right? Display the number counter to 7 segment, and so and then we start the timer. So when the timer out, then we start multiplex here. Okay, but okay, but in the multi segment display, go to the LED, to the multi segment, right? And then control 7, right? This one, command it. We don't want it, we display the leading 0. For example, we have 1, then we display 001. We don't want that 00. Okay, off it. Okay, next, then we set static views to 1 only, because I need 1 only. Remember, this one will be visited each 10 milliseconds. So the wait is 10 milliseconds, for this 10 milliseconds. So in state 0, it will jump to state 0, the first one, because we set this state 0 to 0 and state 1 is 1. So we'll do this one first. So it remains here, right? And let buffer we set to 0, then toggle all that last bit, see, last nibble, the lower nibble, and update that loop, right? That loop. So the loop becomes 0 each time it is 50. So 50 multiplied with 10 millisecond become 500 milliseconds here. So this one will be repeatedly display for 500 milliseconds. Okay, this one, the LED will be toggle. It depends. So LED buffer can be anything. If I said I put 0B 1001, so it become 9 and 6, 9 and 6, 9 and 6, 9 and 6, because all that 4 bit being converted. Okay, next, then here in the loop, right? Each time is the K0 is visited, then we check the switch. So if previously not pressed, now S1 is pressed, then we jump to state 0, state 1. If previously not pressed, then now is S2 is pressed, then we jump to state 2. If previously not pressed and then S3 is pressed, then we jump to state 3. So that's all for the first one, right? For the second one, now it's more the same. So we have loop, we set to 0, right? Loop to 0, index S0 equal to S1 equal to 0. So the first one here, when the loop out, right, the first, then we will update the LED display with whatever from the array S1 with that pointing by index S1, right? And then index S1 is increase, and then if that greater than size of array S1 minus 1, then index S1 becomes 0. Okay, this one, second one. And then after that, then the loop is increased. If the loop is greater than 25 or 250, then it becomes 0. So then this one will be repeatedly will be executed for that next 25 times of visiting this case. Then check the switch right? Catalysis. If previously not pressed, then S2 is pressed, then jump to state 2. If previously not pressed, then S3 is pressed and jump to state 3. Okay. And in state 2, uh, first here, if the loop is equal to 0, then we convert the counter, the present counter. So the present counter for the first one is counter is equal to 0. And then increase the counter. If the counter greater than 100, then counter become 0. So this one will be visited for 100 times. Why 100 times? Because plus plus loop. If plus plus loop greater than 10, then loop equal to 0. And next, the push button is being checked. And if S1 is pressed, then jump to state 1. If S3 is pressed, then jump to state 3. In state 3, if loop out, then array S3 will be update. The LED display will be update with the value of the the data inside array S3 pointing by index S3. Then index S3 will be increased until more than the size of array S3 minus 1, then it becomes 0 again. So it will repeat and repeat and repeat shift for 35 seconds. Remember, in this mode, buzzer will be on, right? And then if the but the S3 is released, this is S3, and then release, then state will change to state 0, and buzzer must be off, right? So that is the code is. Okay, I hope that it will help you to understand how to write code, right? Bye bye.